Hello everyone. Welcome to Tagum City National High School Science Web Course on Quarter 2 Force, Motion, and Energy. This is the third part of our discussion on the different regions of the electromagnetic spectrum. In this video, we will talk about the ultraviolet rays, X-rays, and gamma rays. It was explained in the previous videos that electromagnetic spectrum is the continuous band of electromagnetic waves with varying wavelengths, frequencies, and energy. There are different regions of electromagnetic spectrum as stated. These are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Radio waves, microwaves, infrared waves, and visible light were already discussed in the previous videos. The ultraviolet rays. Ultraviolet rays, or UV, are electromagnetic waves with wavelengths from 10 nanometers to 400 nanometers. This means that UV carries high energy than those in the visible spectrum. They are generally shorter in terms of wavelength than those of the visible light and generally longer than those of the X-rays. These rays are completely invisible to the human eye. There are three basic subtypes of ultraviolet rays. These are the UVA, UVB, and UVC. Each of these subtypes have varying wavelengths. Of the total amount of light coming from the sun, only 10% of it is ultraviolet, and most of the ultraviolet rays, especially UVB and UVC, are absorbed by the atmosphere. UV has good and bad effects to humans and other living organisms. A separate lesson will be allotted to discuss these effects on living things. X-rays are another region in the electromagnetic spectrum with wavelengths ranging from 0.01 to 10 nanometers. They have frequencies in the range 30 petahertz to 30 exahertz, and they carry energies in the range of 100 electron volts to 100 kilo electron volts. X-rays, as mentioned in the previous videos, were discovered by Wilhelm Röntgen in 1895. They are emitted by electrons, unlike those of gamma rays, which are emitted by the nucleus of an atom. The picture on the right shows the first medical X-ray produced by Röntgen. It shows the X-ray picture of the hand of Röntgen's wife. X-ray wavelengths are shorter than those of UV rays and typically longer than those of gamma rays. This means that they carry enough energy to ionize atoms and disrupt molecular bonds, hence called ionizing radiation. X-rays have provided benefits and harm to living organisms, which again will be elaborated later in the course. The last region in the electromagnetic spectrum is the gamma rays. Gamma rays arise from the radioactive decay of atomic nuclei. That is, when the nucleus of an unstable atom disintegrates. These rays were first discovered by the French physicist Paul Villard in 1900 when he was studying the radiation of radium. Gamma rays carry energy up to 8 or 10 mega electron volt. An electron volt is the voltage of one electron, typically a very small amount of energy. But in the case of gamma rays, we multiply a factor of 1 million, which would result to a very huge amount of energy. Because of its high energy, gamma rays is classified as ionizing radiation just like X-rays and UV rays. Scientists sometimes are confused between X-rays and gamma rays because of the high energy they carry. So for them to classify an X-ray as an X-ray and gamma ray as a gamma ray, they usually look into its source. As mentioned, if the source of the radiation is an electron, then it is called X-ray. But if the source of the radiation is the nucleus of an atom, then they call it gamma ray. The wave frequencies of gamma rays go beyond 10 to the power of 20 Hertz, and its wavelengths are very small, shorter than 10 to the power of 12 meter. This video concludes the lesson for the first learning competency of force, motion, and energy, which is to compare the relative wavelengths of the different regions of the electromagnetic spectrum. Before you proceed to the next competency, make sure to answer the summative test number 1. In the next video, we will look into the different practical applications of the different electromagnetic waves. See you there.